Okay, so good morning everyone. This video is going to be on partial fractions, but before we do this, I wanted to give you a bit of an overview of why we're doing partial fractions. In semester one, what you'll notice is that there's a lot of things in semester one which they're sort of prerequisite skills. They're things that don't directly sort of come up. They're skills we need to know, such as the trigonometry skills. But this is actually directly related to Year 12. And I'm showing you this is a Year 12 question in Exam 1, where what it actually requires students to do is to integrate. Now, don't worry about that. We're going to get to that. You're going to get to that later. But before that, the important step, before you can do it, now, how much is this worth in terms of marks? It's worth how many marks? 4 marks. Does anyone know how many marks Exam 1 is worth overall? No, how many marks are in Exam 1? Do you guys know? It's for both methods and specialists in Year 12. Exam 1 is worth, it's actually 40 marks. So this is 10% of Exam 1. And in order to do that, if you, for example, did not know how to do partial fractions, you would get 0. Because, of course, you need to do partial fractions. In other words, you need to change this fraction into something else which is in a certain, looks a certain way, so that way you can then recognise that and integrate, okay, do anti-differentiation basically. That's what's coming up. No, you don't need to know how to do this now, but you do need to know the partial fraction side. Okay, so I just wanted to give you a bit of an overview. Now, we could do that later, no problem. But what we'll do is we will go through and first of all, just talk about what exactly is a partial fraction. So, partial fractions, they come in 3 forms basically. First of all, if we have a linear factor, then that is what we call a type 1. If we have a repeated factor, for example, if I have cx plus d squared, that's type 2, and that actually has 2 factors. It has a factor of cx plus d squared, and it also has a factor of cx plus d, so you have to split it up into 2 those. It's probably going to make more sense when we actually physically go ahead and do them. And then last but not least is this irreducible quadratic factor. I virtually have never seen this in an exam setting. Okay, yes, we can ask you, yes, you will practice them, but often, just so you know, for Year 12, often it's going to be a combination of these. Okay, almost every time. There has been one example in the last 20 years of specialist maths of this type 3. But of course, we'll go through it just in case. Okay, and of course, those ones can be a little bit trickier. Now, what we're going to do then is I'm going to go through, and if you can, in your notes, we're going to do this one together. But before we do that, what we can say is I'm going to show you this equivalent sign, which looks like an equal sign. If we're changing it, but it's the same, but we're changing how it looks, then rather than using an equal sign, we're going to use the equivalent sign. So first of all, we've got 3x plus 5 over x minus 1, x plus 3. And what I'm going to do is I'm going to say that is equivalent to, and you can see here, both of these, you see that both of these are linear factors. Are they repeated factors? No. So this is what we call a type 1. And it could be a combination of both. But as you can see, both of these are just linear factors. So this is a type 1 partial fraction. Now, what we're going to do is, first of all, we're going to call it A, big, and please use big A, not little a, okay? And what we're going to do is it's over the first linear factor, which is x minus 1. And then we're going to add b, which is big B, over x plus 3. Now, I guess what we can say is that if we can find what big A and big B are, this fraction can be expressed as 2 separate fractions, okay, of which in Year 12 Specialist, we need to do that in order to do things such as integration, okay, which is basically the opposite of differentiation is anti-differentiation. And I guess you guys are going to learn that this year in both methods and specialists. Okay, later on in the year in methods for sure. Okay, Now, just quickly, if we have a look at this, you notice over here we do not have a common denominator. So what we can do is we can make that denominator common. So what I'm going to do is I'm going to leave this left-hand side the same, of course. But what do I have to multiply A by, big A, by, so that we have a common denominator? Yep. Yes, x plus 3, good. Okay, and then what we're going to do as well is, so we'll have that over like so, x minus 1, x plus 3. And of course, b, we need to multiply that by x minus 1. And then what we have is we have a common denominator. Now, what would be the next step, you think? Given the fact that this is the same as this, couldn't we just say that the numerator of the left-hand side is equal to the numerator of the right-hand side? We don't have to worry about this anymore, do we? Can you see that? I've got this is equal to that. Okay, so what we can say is my next line is, therefore, we can say that 3x plus 5 is equivalent to, let's just use the equal sign for now because I basically want to find A and B. Okay, so I'm just going to use the equal sign. So just remember that equivalent sign is sort of to say that, yes, this is equivalent to this. It looks different, but now we're just simply equating what A and B are, so we don't need to use that equivalent sign anymore. Okay, so because of course this cancels out, doesn't it? Okay, so I'm not really too fussed about that equivalence symbol. So we've got this, ax plus 3, supposed to be a 3, plus b outside of x minus 1. Now, you can do quite a few things with these partial fractions. You can let x equal anything, really. You're essentially going to get two equations, two unknowns, you'll be able to solve. But in my experience, and I'm sure you would agree, that what could we let x equal to make life really easy and cancel out b? How would I cancel out b? If I was to let x equal 1, exactly. And then what would be the other one? If I've got x plus 3, I'd let x equal negative 3. So that's exactly what we're going to do. Okay, so what we're going to do is let x equal 1. And of course, if you're really good, I'm going to do this. I'm going to say, this implies that. Now I'm going to do this in my head. 3 times 1 is 3, 8. 4a is equal to 8. A is equal to 2. Big A is equal to 2. Okay, so we've found what big A is equal to. Let x equal minus 3. Some of these can be a little bit trickier, but I'm going to do that in my head, and you can do that too. This implies that. You don't have to show all your steps, but if you are making calculation errors, my advice is don't skip too many steps. So x is equal to, b is equal to, did someone say 1? Happy with 1? Okay. I'll trust that you didn't make a calculation error. And okay, so therefore we found A and B. So now we could go back and we can say that, therefore, we haven't really done anything yet, but now we can say that 3x plus 5 over x minus 1, x plus 3 is equivalent to, that's that sign there, and let's sub in what A and B are. So that's equal to 2 over x minus 1. And we've also got, what's b? That's negative, so that's 1, plus 1 over x plus 3. Now, you might be asking yourselves, why am I not allowing you to have a calculator in this test? Well, you could work your way backwards, and if you didn't know a thing about partial fractions, you could do the calculator and reverse engineer, which is something that I'll talk about a lot. We don't want that to happen. So you will not have a calculator for your next test. Now, just quickly, if I go to, how do I get to, I want to get to my calculator. I might have to do this. Okay, so let's open up a calculator and let's check if you're right, if we're right. So get your calculators out now, ladies and gentlemen. In the meantime, I think that I will pause this. No? Okay, so in your calculator, what we're going to do, and I've got to think about this myself because I don't really do it, but if I go to, so in here, we're going to menu, algebra, and I think it would be expand. I think, let's have a look. Now, what I want you to do is when doing a fraction, you go control divide because, of course, we use the fraction tool there. Makes our life easier. And what you need to do is we need to put in our fraction. What was it? X minus 1, X plus 3. And what was on the top again? 3X plus 5. Now, let's see what happens. 3x, what did I do? Oh, I'd put plus 5. Wow. Okay, so that's plus 3. It was 3x plus 5? Okay. There you go. Look at that. Isn't that amazing? Now, so 1 over x plus 3, is that what we got? Yes. So, yes, you can do that. You can also do that, of course, in an exam 2 setting if you need to. So my advice to you would be, I'd be putting that expand and what you're doing and putting it in your bound reference, okay? Now, it's also on video. Let's go back to this. We've just done an example of a type 1 or 2 type 1s. So let's go and have a look at an example here. Now, you can see here that we've got 2x minus 1 over this. Now, first of all, you've got to try and factorise first, okay? Now, this has been, the work has been done for us. So now what we've got to do is simply solve for A and B. Okay, so it's exactly the same thing. I might do it with you guys just quickly, but if you want to race ahead and do it, try it yourself, that is perfectly fine. The first thing is that I guess the step, we can really go straight to this step. 2x minus 1 is equal to A, so I'm getting that minus 2 over that side, and we're also getting this B, and we're multiplying that by x plus 3. And just like before, we're letting x equal, I could let x equal anything, but it would be easiest to let x equal 2. Now that implies that, what's that, 4, 3, 3 is equal to 5b. 3 is equal to 5b is what I got. So therefore, B is equal to 3 on 5. That's what I got. Maybe it's wrong. I don't know. We'll check in a moment. But then now what we've got is let x equal negative 3, which means that we've got negative 7 is equal to negative 5a. So, of course, I've got a is equal to 7 over 5. Okay, so I've found A and B. I hope that they're right. It's just saying solve for A and B. So really, I guess if you're asking to be expressed in partial fractions, you'd need to state what it is. I guess what you would write, therefore, what we can say is that 2x minus 1 over x squared plus x minus 6 is equivalent to 7 over 5. I'm going to put the 5 down there. That would make sense. X plus 3 plus b, which is 3 on 5, x minus 2. Now, I'm going to go and do that on expand again so you can practice. 2x minus 1. Let's go over here. And you know what? When I do this, sometimes I get a bit lazy. So I get this, I press enter. What happens if I press enter? What's going to happen? It copies it down there. Okay, so what I'm going to do is, what do we have on the top? It was 2x minus 1. And on the bottom, we had x squared plus x minus 6 or something. x squared plus x minus 6. Okay, yes, you can factorise, of course. Okay, press enter. Is that what I got? Was that correct? 3 x on x minus 2 plus 7 I'm on YouTube here. I don't want to make a mistake. Okay, believe me, I make plenty of them. Now, are we happy so far? That's a type 1. That's for the most part what you're going to get, okay? But let's go quickly because I'm mindful of the time. Look at this one. What type is this? What type do we have here, ladies and gentlemen? We have a type 2 and a type 1, don't we? We've got a linear factor. Now, here's the trick. We've got to split that up. That's going to be one separate thing. But over here, this x minus 1 squared is going to be a b and a c because there's actually 2 factors. That's where it gets a little bit trickier. And it means that we have 3 things to find. I'm going to very quickly do this because I think you guys and girls get the idea. Now, what we're going to say is 2x plus 10 over x plus 1, x minus 1 squared is equivalent to, I'm going to just do A, big A, with my linear factor first, which is x plus 1. Then I'm going to do B, and I'm going to do one of the factors of x minus 1 squared, which is x minus 1. And then thirdly, I have another factor, which is x minus 1 squared. Okay? Now, what we need to do is we need a common denominator. On the left-hand side, we do have a denominator, or it's all one thing. Yes, Ben, just one sec. I'll just... Okay, so a good question there, basically, because this is the type 2 part, and we've got 2 different factors. One's a linear factor, and one is a quadratic factor, the x minus 2 squared. Now, what we're going to do is we need a common denominator. So what would I have to multiply a by? And we know that in the past, we've always just cancelled out that denominator. What do I have to multiply a by? X minus 1 squared. Absolutely. Fantastic. That's great. Because I want you to go from this step, ladies and gentlemen, directly to this step. Okay? I don't want you to create extra work for yourself. X minus 1 squared. Plus b. Now, what I have to multiply b by, it gets a little bit trickier. X plus 1, x minus 1. And c, well, that's a bit easier, x plus 1. Can you see there? Can you see how I can go from this step to that step and you wouldn't lose any marks? Okay? So don't create extra work for yourself. Now, what I'm going to do is, of course, for me, I'm going to let x equal 1 for starters. Because, of course, that will cancel out this term. It'll cancel out this term, and all I'm going to be left with is that I can find c straight away. So when I let x equal 1, that's going to give me, on the left-hand side, that's going to give me 12 is equal to 2c. So therefore, c I can find is 6. Okay? Now, I found c. It probably makes sense to let x equal what next? What would you let x equal? Let x equal -1, because that's going to cancel out a couple of things as well. When I let x equal -1, I'm going to do it in my head as quickly as I can, but if you're skipping steps and making mistakes, then my advice to you is take your time. Okay? So -2 plus 10, so I've got 8 on the left-hand side. Now on the left-hand side, we've got this -2 squared is 4. So that's going to be 4a. And of course, I'm going to have 0b and 0c. Well, that's quite nice. I got a is equal to 2. No, you don't have 2b because -1 over here will make it 0. Yep. Okay, now, now, ladies and gentlemen, I have just let x equal -1 and 1. We've just found 2 of our 3 unknowns, though. So now, I guess the easiest thing, in my opinion, is let x equal 0. Okay? Let x equal 0. What we've got is, we've got on the left-hand side, we have 10, and on the right-hand side, negative 1 squared. So that's going to be A, negative 1 or negative B, and plus C. Now, since we know what C and A are, I'm sure you can find for me. So 10 is equal to A, which is 2, minus B plus 6. So I've got B is equal to 8 minus 10, which is what? Minus 2? Now, are we done yet? No, because now we need to actually physically write out what, it's a lot of work, isn't it? So what we've got to do, last but not least, is therefore, when it says resolve into partial fractions, don't just say what A, B, and C are. I want you to write for me, therefore 2x plus 10 over x plus 1, x minus 1 all squared is equivalent to, and I want you to fill in A and B and C. And if you are ever unsure with these on how you went, you can then just simply check on your calculator. Now I've got a plus there. I probably want to change that. I want to change that to a minus 2. Okay, and that's a minus 2 over x minus 1. You can check that, ladies and gentlemen, on your calculator right now. And I'm hoping that we haven't made a mistake. And that, of course, is what I want to see. This is what I want to see for full marks. Now, if this was something like this was worth, let's say 3 to 4 marks on an 11 special, then of course this will be your final answer, expressing it there. Finding A, B, and C might sort of be, you know, it might be, definitely expressing this will be a mark. Okay, maybe expressing this will be a mark. And then finding A, B, and C would be all correctly, I guess, another mark as well. But of course, you wouldn't get your final answer mark until you did that. So let's just say if it was worth 4 marks, yeah. Okay. All right. Now, here's one I prepared earlier. Okay, and this is for the irreducible quadratics. Now, I don't want this video to go forever, but I want you to see here. Can you see here that we've split up this partial fraction into a linear one, a over x minus 2, but this is an irreducible quadratic. It means it can't be factorised. So that has a linear factor of bx plus c, and that is how you do type 3s. Now, I'm going to spend less time on them because I do want you to do them and practice them, but as you can see here, what we can do is we then expand that out, and we need to, in this case, I've let x equal 2, I've let x equal 0, and as you can see, that expands out to me, I've got a linear factor over here, and I've also got this minus 2x minus 1 over here. I've got this minus 2x minus 1, which implies that, that I've actually found what B and C are. Okay? That's where that's come from. You won't see it as often. You definitely won't see it very often in Year 12. It has come up though. It has come up a few years ago. But that's the one and only time I've seen it in 20 years. All right? Now, that being said, I think we are due to stop soon, so I'm going to stop there. Just one thing I will take note of is, in your next class, we're going to go through, if the numerator has a higher degree or equal, we need to do polynomial division before we begin partial fractions. Now, we're going to spend some time on this, but as you can see over here, we basically have this becomes this, and this becomes a partial fraction, which we can actually simplify as well. Okay, I'm going to stop there. Are there any questions?